if I reach the button, yeah, here it is. Can you see it properly?
Yep.
Yes,
Okay.
yes.
Okay, good. So without repeating what Ayush already said during my intro, I'm based in France actually, and I am a part of an organization where my colleague Michael Osesek, who is already attending this, also attending this meeting here, and by the way, Michael will be the the moderator. He will answer questions live, if you post some questions in the chat. What I will do as well, I will have 2 breaks between my sections. So if there are live questions, I can also answer live questions after each section, if you have questions. So yeah, so my position is very much finding solutions to for operators and vendors and integrators who are testing RAN or Open RAN. It's not just limited to Open RAN, sorry. And actually, this presentation here overall is not strictly limited to Open RAN. Of course, Open RAN brings new features and new very interesting ways to optimize energy, bringing intelligence into the RAN, and the modularity as well of the architecture of the RAN helps to optimize the way the network can be used to reduce the consumption of energy. But basically, we have also the same solutions applicable for just E node Bs or G node Bs as a single piece of equipment, or yeah. So yeah, so that's not just for the future. It's already usable with the legacy architectures. Okay, let's move forward. So basically, it's very straightforward. I will maybe set up the scene, basically, what we mean by optimized energy efficiency. What are the different techniques based on ETSI specification, by the way, initially. And second part will be more on, technically speaking, what it takes to measure, benchmark, optimize the energy efficiency of the different elements of the network. And last but not least, because you may think that all this is kind of a dream, I will illustrate that with some real cases, some real demos or real usage of that is available, of course. Okay, so let's start with energy efficiency. Do I need to explain or to remind everyone that energy is very important? Probably not, right? Hopefully not. Energy, in particular for a mobile operator, energy is very key. Also, there is this big push from the population, from the customers, that we should be more energy safe, and also for the operator to make sure that is less susceptible to the change of the prices of the energy, of course, like we experienced a couple of years ago. It's not far away. But basically, you know that in the network, 80% of the energy, roughly, is used by the radio access network alone, and that means that it's very important to look at that carefully. And also another number that makes very much sense is the fact that overall the energy represents 20 to 40% of the overall operation expenditures. So that's very, very significant from a cost perspective, right? So let's have a look on what it means. Well, it's possible always, you know, to reduce energy consumption. We can use equipments that are less, let's say, hungry of energy. We can use different techniques, you know, to shut down some antennas at night or this kind of things. But at the end of the day, what really counts is to strike a balance between energy savings and the impact of on the customer experience, on the network efficiency and the customer experience. So it's all it's to try to find the right balance, and that balance is very unique to each operator, to each network architecture. It's a very complex formula. It's actually not a real formula that you can compute easily, right? It's more like something that must be evaluated and optimized and continuously optimized actually. So this is fundamental because it's not just about measuring the consumption of energy. At the same time as you measure, when you want to optimize the energy efficiency, at the same time as you measure the energy consumed, you must put that in perspective with the impact on the user equipment, or at least on the end users from a QoE perspective, on the network architecture, on the customer experience, on the network performance. It's all these kind of things that must be considered all together. And you will see later in my presentation, when we measure this kind of thing, when we evaluate the energy efficiency, we have a very complex. Let's say we have multidimensional graphs that shows the impact of one parameter on the others. So it's very important to put every change in the network configuration in perspective with the impact on the other parameters. And the complexity in the new forms of networks comes from the fact that the networks are more and more heterogeneous. It's not a single vendor approach. Well, that's still the majority of the networks, of course, but even within the single vendor approach, is not a single architecture or single let's say model that is used. For instance, there could be different protocol stacks and changing protocol stacks. There could be different strategies in terms of, should my network be very much centralized, meaning all the elements like the DU and the CU and the MEC and everything in a single location, or should the DUs be distributed next to the RUs in the cell sites? That's a decision to make, and it has an impact on the energy consumption, of course. What technology is used? Is it aggregated, disaggregated? Is it virtualized? Is it clusterized? Is it based on Kubernetes VMs, or is it just bare metal? And last but not least, when it comes to the ORAN in particular, but let's say to the infrastructure supporting the virtualized applications, like for instance the DU and the CU, there are different accelerator techniques that can be considered, like the inline or look aside, and of course each of them have a different impact on the energy consumption or optimization. So you see there's several moving targets, and we need to evaluate that all together, find a way to find the secret source that is ideal for each case, for each network. So basically, it's based on the correlation of data, like I said. And last but not least, very important as well, the test method has to be automated. Why? Because, as I said, there are lots of parameters to be tuned to optimize the energy consumption. So, of course, I mean, if you change a parameter, you need to redo all the measurements and make some conclusions out of it. And you have to change the parameter or the parameters again. So basically, it's a continuous effort that has to be done to find the best compromise between energy consumption and impact on the end-to-end performance and QoE. And that is, of course, much easier if you have an automated test bed, because it's automatic, and then you can also benchmarking what you get against maybe a reference implementation that you tested initially. So I don't have any crystal ball. Of probably nobody has. And the typical question that comes at this point in the presentation is, that's why I put that slide actually, but will Open RAN be a solution for energy efficiency? Okay, or is it just another hype topic? Well, that's my perspective, or maybe that's Keysight's perspective as well. Open RAN or vRAN doesn't need to be strictly speaking Open RAN or virtualization RAN like it was implemented by Rakuten initially in Japan, for example. Well, they give the possibility to really have access to lots of parameters in the network, including in the RAN, including, for instance, the CPUs and the way the CPUs are used. You know, we can play with the C states and the P states of the CPUs, but I will come back to that later. So you can optimize the consumption of your computing infrastructure. Also, there is more and more apps available for the RIC. Well, the RIC is a very important, very key component of the Open RAN for sure. It's not yet deployed, but there are lots of research by the vendors as well as by research centers, universities, or funded projects by the different organizations like European Union and in the US as well and the UK as well. So lots of things are happening there, and I will illustrate that with an example we were involved in. But XApps and RApps in the RIC can really make a difference in terms of energy consumption. So it's very important to consider that. I think it's a matter of time. So initially today, probably the monolithic or the RAN, the traditional solutions from the RAN vendors are optimized for energy efficiency, correct? Because the vendor has access to all the components that are used inside of the RAN, so it is optimized by nature, let's say. But over the long term, Open RAN, because what I wrote on the left-hand side should provide better, more efficient, and different ways to optimize the energy consumption in a very sophisticated way. And in general, I mean, we are in the technology altogether, right? So we should trust the innovation. And the ORAN ecosystem, there is a lot of innovation. I mean, lots of new companies bringing solutions, proposing alternatives. So that should provide some good ways to optimize energy in the future. In the short term, we can already see the early adopters of Open RAN, in particular the greenfield operators, and in the US or in Asia that got some benefits from this Open RAN approach. All right. Let's make maybe a break at this point. Are there any questions, Michael?
Yeah, sorry, I was finding the unmute button. So Stefan brought a good point with regards to how to, let's say, eventually connect the energy supply situation and also demand situation from external to the RAN into the RAN domain, right? And that's something I just said, obviously is achievable if you follow the RIC concept and the apps running on that, taking outside perspective of RAN, in this case, energy supply and demand, and then modulate that into the network configuration topics, right? Said that, I'm not aware that this has been exercised at a trial or POC somewhere, so it's an interesting topic we could follow up. Actually, we have a research project with Keysight and Fraunhofer and other colleagues where we had an idea to, well, obviously it's nothing new, wind energy harvesting is out there, and we wanted to include this into an energy efficiency project, but then the partner providing the energy, the wind mill didn't join the project, so we couldn't exercise that. But it's a good point and maybe worth following up.
Well, like you said, Michael, the RIC is part of an end-to-end service orchestration mechanism.
Yep.
So at the service, all over service, if there are some instructions or constraint or request that comes to the RIC, we can imagine in the future an app, an R app in particular, could in the SMO could take that in account and make the changes on the network that are required. Yeah, we can imagine this.
Correct. Yeah.
Okay, so let's have a look at a little bit deeper into the technology now, which is how we're going to test this, how we're going to optimize the energy efficiency. Well, first of all, if you consider a test lab today, a test lab from an operator, but today the test labs are mainly in the tier one operators, but we have also in Europe in particular independent labs that are fully equipped to perform those tests. I'm thinking about I14Y lab in Germany or Digital Catapult in the UK, and there are also other SIs in Europe. Don't want to give the names here, but they are also equipped, or they want to go into that activity of performance, conformance, and energy efficiency testing. Okay, so there are resources around. I mean, I'm thinking about an operator that may not want to deploy a lab on his own to perform these kind of things, because energy consumption, or what in Keysight we call the E-plane testing, E for energy, obviously. The E-plane testing comes as a next step after the other type of test have been performed. In particular, the conformance or vendor selection, basically testing the different components. I will activate my laser here, like testing an RU here, but could the same for testing a DU, a CU, or a RIC. Can be done, in isolation. So that could be for conformance, performance, security purposes. After that step, typically there is the overall end-to-end integration and performance testing end-to-end at the G node B level or E node B level, where we can do also security tests. So that is very, very well standardized, I would say, as a methodology. If you take those components and you just add power supply, power analyzer, basically power measurement, plus some automation and reporting, like I said before, to make sure you have this continuous testing in order to compare what you get from what you had before, benchmarking, comparison. Then you have a test bed for energy efficiency. Okay, here the illustration is just based on RU, but it can be the same for the G node B level, the CUDO level, or the RIG level. Okay, and I will show that later. So its continuity is the next step after what was classical in the test lab. So first one is, and I will show three cases here. One is the RU, radio unit, because it's very special animal, dealing with the RF, dealing with the layer one. And later, next page will be more on the CUDU, which is the computing of the protocol stacks in the RAN, all virtualized these days, software-based, running on servers or in clusters in the cloud. And I will show that later. And then finally, the RIC as the intelligent brain to optimize everything, including the energy efficiency in the RAN. Okay, so as far as the RU is concerned, the methodology is fairly simple. The idea, and it's based on the ETIS specification, you can see here. The idea is really to emulate different traffic profiles at the layer one, so at the RF level. Well, in the case of Open RAN, is digital RF on the open front hall, and it's real RF on over the air, right? And to test the energy on a per RF port basis. So that's why we have a switch to switch from one port to the next. If you have a 4x4 MIMO antenna, of course, you need a switch with 4 entries. If you have a massive MIMO, it's going to be more complex, right? But it's also possible. And then we have just an RF probe to measure the RF power downlink. Okay. Well, when I mentioned the, and of course, we supply the energy in a very controlled manner with typically a power source, more than the power analyzer in this case. Power source so we have a 48-volt power source, which provides us KPIs on the energy that is consumed in real time. So we collect all that parameters and we provide results. Well, when it comes to massive MIMO, oh, sorry, there should be another. Okay, I've got an issue of animation. Yeah. So if we consider massive MIMO, the same technique could be used, but more efficiently, we can use an RF equipment that is made for testing massive MIMO. So basically, it's an equipment that has multiple ports, and all the ports are tested simultaneously in parallel from an RF perspective, including from a power measurement perspective. And that is, of course, provides an advantage. So you test all the ports simultaneously, but it provides also another advantage. If you consider massive MIMO, it's because you want to implement some beamforming. So it can measure the power per beam, not per port, not per RF port, but per beam. And that is really what counts at the end, because the end user, the UEs, will see the power of the beams. They will not see the power of each of the individual RF port of the massive MIMO antenna. So that is a possibility that we can provide as well. So that was for the RF part, the RU. Now, if it goes to the DU-CU, so DU-CU is a software, right? Typically today, both CU DUs are provided by the same vendor, but in theory, from an Orion Alliance perspective, each of them can come from different vendors running on their own servers in a bare metal way or in a virtualized way. So sharing resources like NFV and with the VMs, but also possibly it can run in the cloud, and that already exists in real. So I mean, if you go to Dish in the US, they implemented some of their software functions here, DUCU, in the cloud. I think it's Amazon cloud, not 100% sure, but anyway, so basically you have the software running in some kind of computing, right? So the idea here is to simulate end-to-end a realistic traffic, and by realistic I mean multiple UEs, could be many UEs emulating traffic, could be small traffic, medium traffic, a large traffic, okay, each of them, and each of them belonging to different groups which are more or less far away from the antenna. So basically we apply a pass loss fading to each of the UEs. So basically we simulate a real case where you have a lot of UEs simulating different kind of traffic profile at the application level, and they are located at different distances from the cell. Okay, so realistic again. And at the same time, we are going to measure the energy that is consumed by these DU and CU. Okay, and we can do that just by using the default setup, or to make the game even more complicated and the optimization of the energy even more sophisticated and optimal, you can also play with the C states and the P states of the DU and actually of the CPUs running the DU and the CU. If you're not that familiar, the C state and the P states, the C state is the sleeping mode, basically. Okay, so basically at a low traffic context, the CPUs can fall into different level of C states where they are basically not running full speed all the time. Okay, and the P state, I call it the velocity state. Actually, it's by playing on the frequency and the voltage of the CPUs, you can basically force the CPU to be faster or slower. So basically, it could be the performance state or velocity state. And by playing with those C and P state variables, you can, of course, reduce the consumption of the CPU, okay, and basically of the DUCU. The thing is, you have to be careful because if you go too far with that game, you will impact significantly the capacity of processing what is sent end to end, and then you will impact, of course, the quality of service and quality of experience. And energy is measured again here at the same time as you play with those parameters. We can use for that a power source, again, a power analyzer. But power source and power analyzer are difficult to use in a virtualized environment where that basically the servers are not dedicated, they are not identifiable. In that case, a better technique, which we use as well when needed, is to use Redfish, which is a feature of the servers. Most of them support it, so you can measure the inside KPIs of the servers as an infrastructure. So basically, different kind of thing, including the energy consumed by the servers. Okay, and granularity can go as little as on a per CPU basis. And if it is in the cloud, it's even more complex then because you don't even know where the servers are. So basically, we can use a technique called Kepler. Kepler is basically a mechanism where you can measure the consumption on a per cluster basis in a Kubernetes clustering. So then you can measure the consumption of the different clusters. So basically, you can measure the consumption of energy of where the DU is running, of where the CU is running, and you have different instances distributed. You measure the energy of each of them. Okay, and you aggregate all that in a specific application, which we call the E-plane test platform. Okay, so that's the way to measure and optimize the energy on the CUDU. I will show you an example afterwards. Last but not least is the RIC, a very important element of an ORAN architecture. So basically, the RIC provides two levels of real-time and non-real-time infrastructure to run applications. At the real-time or near real-time, basically the XOPS can reconfigure and play with the configuration of the DU and the CU typically through the E2 interface. And at the non-real-time, the XOP, the RApps, sorry, they're called RApps running in the SMO as well. They can play with the O1 interface towards the DU, the CU, and also through the M plane, they can play with the RU. Of course, they can also exchange information with the XOPS through the A1 interface. Okay, so that's the theory. And basically, the idea behind that is that the RIC is going to continuously monitor performance metrics and optimize the configuration of the network for certain purpose. Okay, so each XApps, they have their own purpose, right? Some are made for energy efficiency, typically in the RAP level. Some others are made for slice performance efficiency or slice QoS control. Could be as well and I'm going to use that in my example later, an XUP dealing with traffic steering. Okay, so moving the ongoing connections from one radio unit to another radio unit, which will be important if you want to switch off that particular radio unit, okay, and save energy, of course. So you see, you can play with that, and there are lots of experiments going on, and they are already demonstrating very good efficiency. So the platform basically is based on the simulation of the network in red in below. So we simulate multiple UEs, multiple RUs, multiple DUs and CUs. Basically, we simulate a network at scale, okay? And we simulate the behavior of that network over time. and we will look at how the rig is behaving in this kind of situation. And as well, because we are simulating with different models real elements like RUs, for example, we know how much a particular RU is consuming in terms of energy. And through the simulation, we can calculate how basically the effect of the request from the rig, how they are decreasing the energy consumption, because they force the RU to go in a sleeping mode, for example. Okay, so this kind of thing can be measured in real time, and of course you can push some reports out of it afterwards. But basically, it's a very good way to experiment and verify the way your rig will perform or will contribute to the energy efficiency. So that was maybe too much of theory. It's not theory, actually, it's real. And to illustrate that, I'm going to use different things we have done last year with different organizations. You know them, of course, maybe not so much the NTIA Rig Forum, because that's very new and it's in the US, but you know Mobile Rig Congress, you know the Plug Fest, which is the biannual event from the Oran Alliance for interoperability test, and Fuse, which is the TIP event, which was in Spain before, and last year it was in Dublin, basically where everybody talks about RAN, Open RAN, and different aspects of the practical deployment of the RAN. Okay, so this is the real elements, and that was with Fuse, the real measurements that we made with, we had an ODU emulator here where we had an ORU in the middle, a power source to measure the energy absorbed by the ORU, and we had in between the switch, front hall switch, between the ODU emulation and the real ORU, and at the RF side, we have a power sensor. Okay, nothing special. And what of course, we can measure how much energy this RU is using. But to make the game a little bit more complex, here what we have done, we have simulated some attacks, DOS, denial of service attacks on the servers or on the elements supporting the ORU. And here we can we play with a control plane and synchronization plane, by the way, to disturb the ORU and see the effect on the energy consumption. And we went a little bit further. We also simulated that there was a second DU which trying to connect to that particular RU, but with a wrong configuration. And then we could see the impact of this second DU, which was, of course, using resources in the RU, and we could measure the impact on from a power perspective. So basically recreating real life scenarios in the worst case. Okay. So that exists and is definitely available. The second case was demonstrated with different partners at Mobile World Congress. So it was made in Europe with different players, vendors and operators. And basically the idea was to test the energy consumption of a DU, a CU, and the O cloud, basically the cloud supporting basically the data center infrastructure supporting the DU and the CU. And we played with everything I said before. We played with the C state, we played the P state, we played with the different level of traffics, and for different level of traffic, we could definitely measure that by optimizing the C state and the P state. And actually, in this particular case, the C state and the P state were not manipulated by us, but they were manipulated by an energy efficiency application running on top of the CPUs, basically looking at the traffic level and the processing level and basically optimizing the configuration of the CPUs in real time. And we could measure that at the different traffic level, high, average, and low, we could gain a very significant energy saving. So that is real, right? I mean, of course, the DUCU doesn't consume as much as the RU, but it contributes a lot to the energy saving, definitely. That's real, and that's published actually. There are data sheets or white papers and different publications available about that. And we could show as well what I call the breaking point. So basically, you know, this is one of many different graphs that are available, but fundamentally we measure in red the throughput through the DUCU. At the same time, in red, we measure the power that is consumed in yellow, okay, power consumed, and we change the P state step by step, okay, from the high P state, so the maximum velocity of the CPUs, to the lowest velocity of the CPUs. And we can see that P state has an effect, definitely has an effect, and that effect is this 20% that we could measure, of course, but we shouldn't go too far. So, and this is very important on the per CPU vendor or per server vendor. It's different, but you need to as a network operator to evaluate how far you can go with this. Okay, because if you go too far, of course the CPU cannot cope with the traffic anymore, and could have different behaviors at that stage, right? But in our particular case here, all the processing stopped basically, and the throughput dropped to zero, okay, immediately. So that is not what was expected, right? So basically, we know that in this particular case, the P state should go up to somewhere here maximum, right? So we should configure the software in context with that. Okay, for matter of time, let's go through the last but probably the most exciting use case, which was demonstrated during an event in the US managed by NTIA. And then here we were partnering with two ops vendors, AirOps, sorry, there's no S, AirOp for energy saving our app in non-real-time RIC, and with the Polish company Rimedo providing a traffic steering XApp for near real-time traffic steering. So the idea was to make those apps working together to monitor what is the traffic demand, what is the usage demand from the UEs, and if the demand goes below a certain threshold, is to offload the network by shutting down some RUs. Okay, and of course, if you shut down the RU, you consume less at the RU level. Okay, and the RU again is where you consume a lot. So basically, with this mechanism, we could show, and by the way, it wasn't done like with a, let's say, optimized traffic profile. No, it was done with a traffic profile, a real life traffic profile provided by Vodafone. So it was based on a real situation, but of course simulated in a lab, where we could see that at the low intensity traffic during the day, we could really manipulate the ORUs to consume less. And we wanted to measure as well that by doing that, or while we're doing that, we keep the accessibility and the performance of the network at the top level. And actually, we achieved pretty much no impact on the end customer, like 99.999 accessibility. Okay, so the way it looks is the following. So in the RIC test, which is our RAN simulator, if you want, we simulated 3 macro cells and 3 small cells or performance cells. Okay, and the idea was when the traffic is low enough, we will stop the small cells, okay? And we will just keep the macro cells. And of course, depending on the topology of the network, there are different scenarios possible, right? So what we're going to do with the rig test, we're going to play with multiple devices and different profiles, like I said, based on the Vodafone traffic profile provided. A mobility schedule, we can move, of course, the UEs from a cell to another, like in the real life. We can play with the different QoS, QoEs, different traffic at the application level, and using network slicing if available. I mean, that's not a mandatory thing, but that's a possibility as well. And we play with that, and we feed basically the rig with the information through the key performance metrics or the radio control information, etc. And then the XApps and the RApps can digest the information and take the right decisions. And in this particular case, what we will see is that we have an initial state where each of the cell, they have 50 UEs connected. Okay, why not? And there is a certain traffic level that is going through. And when we activate the energy efficiency mechanism, we will see over time that the UEs are detached from the small cells, and they are going to be attached or handovered to the macro cells. And at the same time, we continue to measure all the KPIs of the network, and we measure the energy, we measure this kind of thing. And because we know how much the different cells are consuming, that's part of the model that we can configure, we know how much energy we save. Okay, and this is how we could demonstrate the 25% saving. And that's it. I hope it was not too fast or too complex. I don't know, Michael, if you have lots of questions or.
Yeah, we had some, and there's actually one new one. Basically, the handovers are initiated by the rig without any traffic loss. Yes, I think that's the trick, right? I mean,
yes,
to have seamless experience, seamless good experience for the subscribers.
Yeah.
And that was the traffic steering app, which then obviously utilizes standard 3GPP signaling to initiate the handovers and not having dropped calls.
Yeah, actually, we use there are different mechanisms that are possible, and there is a very, very good white paper from Rimedo, if you want to go there, that explains these two mechanisms that are possible. But one of them is based on the cell configuration and control, which is a mechanism through the E2 interface, where it's possible for the XApp to reconfigure and have some actions on the cells. So yeah, that is true. I mean, we didn't lose any core that was visible somewhere. There was zero. Maybe not here. Somewhere in one of the reports, I didn't put all the pictures here, but basically we could show that there was no call that were dropped, and the performance remain good. Yeah. And you have the consumption per cell here. You can see on this graph, for instance, as well. Okay. Yeah. Sorry, Michael, I interrupted you. Maybe.
No, perfect. Yeah. So thanks, Yvonne. Maybe some remarks. I think what we did show and what we worked on over the last years is to make to show that those capabilities are there and they are working, right? I mean, experimental setups and plug fests and trade shows, demonstrations. There's a lot of research happening in this area. I think the challenge now is to operationalize that, right? And that depends obviously on the strategy of the different mobile network operators, and say, okay, how much effort do I spend going into this area of energy saving opportunity? Which again, the reward could be great because of it's a major contributor, but it also depends on the vendors, right? The ORAN vendors, the incumbent vendors, if you like, how much of those technologies are they going to adopt and implement immediately. The Oran Alliance, as an example, is putting a lot of effort into specification and standardization of those aspects, like Ina Bowen mentioned this, what is called service model for a rig, which basically is the set of parameters which can be retrieved from the infrastructure to make decisions and the control capabilities which are exposed. All that needs to be implemented. And that's obviously a roadmap topic, et cetera, et cetera. So I think the bottom line here is there's very interesting capability coming from those standards and specifications in Oran Alliance, and also from 3GP now. But then it depends on the priorities mobile network operators are putting that. Eventually, then reacted by the reaction of the vendor ecosystem to implement
that. Definitely, I mean, you touch a good point here, because so far, actually, until even now, it was based on a very simplistic specification from the ETIS, which was based on just E node Bs and G node Bs. There was no like concept of disaggregated RAN at that stage, and basically we Keysight extrapolated that into an ORAN architecture where we separated what is relevant for the ORU versus what is relevant for the CUDU. But that is now going to be adopted by the ORAN Alliance on one hand and the ETSI on the other hand. They are working on new specification for energy efficiency. So that will become available for the whole mobile community, not just the ORAN. Yeah. All right. Any more questions? Sorry, Ayush, I was too fast at the end.
No, thank you, Yvonne. I was about to say the same thing. If you have any questions, you can unmute yourselves and ask live, or we have a new question in the chat section from Vazek. What about how to manage conflicts generated by different R apps?
That's a big topic. It's a topic actually that most of the universities in Europe are working on. It's a lot of activity going on right now. The mitigation of the conflicts between XOPs, RAPs, or multiple XOPs altogether, right? I don't know how that will be made at the end. I don't know, Michael, if you have some other insight there, but it's a question, definitely. The only way to do it today, if well, apparently there are some ways, right, or at least some rules that could be followed by each of the apps, and we can verify what happens. We can check the behavior of them together, right? That's the purpose of a rig simulator, right? It's really to evaluate what's happened.
Yeah, I think there are also one attempt is to use kind of watchdogs to try to detect those conflicts. But then, of course, the question is, okay, what is the corrective action, right? And that's eventually maybe about priorities. It's a good topic. I think we need to maybe, I don't know if we have some examples where we saw we didn't did this type of exercise in a plug fest or something. That's not only related to energy efficiency topics, right? It's a general rig topic.
It's a general topic, yeah.
What to do there. But yeah, it's, as Yvonne said, a topic of research.
Yep.
Okay, maybe we can take it up in a later session or even offline, have a discussion on it. Thank you, Michael. Thank you, Yvonne. I'll just take over the screen for 1 second. Thank you, everyone, for joining in. As part of these webinars, we request you to also share your feedback with us. This helps us improve and also plan for future sessions. You have a QR code on your screen right now, which you can scan, or even click on the link in the chat section, which you can share the feedback with us. It can be anonymous, or you can share your details. Up to you. It does not take more than 2 minutes. Once again, Yuan and Michael, thank you for sharing Keysight's insights with us on the next generation of Open RAN and how energy efficient it can be. Yeah.
And
Thank
I don't
you,
know
everyone.
how you can reach me eventually, but if you're interested, we can talk about that in more details. No problem.
Absolutely. If you,
we will.
Yeah.
Yes, Michael.
Yeah, exactly. So any follow up, just contact us. First name, last name at keysight.com, or visit us at the Mobile World Congress, of course.
Exactly.
We have a booth there, which I heard should be really, really nice this year, a new one. So maybe worth stopping by. And yeah, also thanks from my side for joining, and looking forward to discuss it further.
Definitely. We'll share the slides and the details of the video recording, and of course you can even reach out to me if you want to connect with Keysight, and I can help you with that. Yeah,
I will share you the latest version, Ayush.
Sure, Johan. Thank you very much. Thanks again for everyone joining. Enjoy lunch. Yeah.
You too.
Bye-bye.
Thank you. Thank you, everyone.
Thanks, guys.
Bye-bye.
Thank
you very much. Bye.
Bye.